so this problem asks us to find the point on the line y equals x closest to the point 1, 0, 1, comma 0. And the hint that they give us is that it's easier to minimize the square of the distance. So we'll see what that means. So first of all, let's draw a picture of what we're looking at. So this is our, now we're living on the xy plane. Okay, and y equals x is this line here, the one where x equals y basically, all the way along. Okay, and the point 1, 0 would just be, let's say, right here. Okay, so that's 1, 0. So we're trying to find what is the point on the line that is closest to this 1, 0. So here's 1, 0. Okay, so here's the line y equals x. We'll just keep that in mind here, and we'll see where we go. So this is the distance. All right, so let's use the distance formula. So we have some x point, some xy point, and actually because our y equals x, we can replace the y with another x. Okay, so that's useful. So instead of saying that, we can say x comma x. Okay, so then we have that, and our other point is 1 comma 0. So to find the distance between the two, let's just plug it into the distance formula. So we have x minus 1 on one of them, and then plus, and that's squared, and then x minus 0 on the other, and we're going to square that, and then square root of it. Okay, so then we get d is equal to the square root, so this is just 0, so x minus 1 squared plus an x squared, okay? So then at this point, this is where our hint comes in. So if we try to minimize this, because distance is now function just of x, right? So this is kind of like our d of x. If we try to minimize this, that means that we're going to have to take the derivative, which involves this annoying square root, right? But minimizing the square of the distance, so like d squared, as opposed to just d, that's the same thing as minimizing distance, right? Because distance already is should be a positive value, right? And then when you square it, it becomes even bigger. So anyways, this is what we're going to minimize. That's what we're aiming for. So our distance squared is going to be x minus 1 squared plus an x squared. Therefore, see how the square root was taken out? So that makes our lives easier. So now that we have that, we can simplify a little bit. So then we have x squared minus 2x plus 1 plus another x squared. Okay, so distance squared is going to be 2x squared. We have two of those, and then minus a 2x and plus a 1. So this is our new formula here. This is what we're going to minimize. Right, and we'll continue this on the next slide. So now we have the distance. I'll just call it distance just to be general with it. Okay, so we already know it's in our brains that it's like distance squared. So d is equal to, or I'll say d of x actually. So d of x is equal to 2x squared minus 2x plus 1. So if we try to optimize this, we're going to take the first derivative of it. So d prime of x is equal to 4x, and then we have that minus 2. And there's no place where this doesn't exist, so we have to set it equal to 0 and see what our x value is. So that's just going to be 4x is equal to 2. And then we get that x is equal to 2 over 4, which is the same thing as 1/2. Okay, so this gives us the x value of our coordinate, and which also actually gives us the y coordinate, right? Because x is equal to y, we're on that line there. So our final point is going to be a 1/2 comma 1/2. Okay, and pictorially, so this is our answer, and pictorially on the graph, it looks like this. So if this is 1, and this is 1 there. So this is 1, 0, that's our point. And then here was our y equals x line, so something like that. And the closest point would be 1/2, 1/2. So that would be right there, which is actually perpendicular to the line. Okay? So that is all. That does it for the question, and that's all for this concept, for the practice problems video, on applied optimization. I hope that helps, and happy studying.
To give me that love and that I